this is negative and why this outflux is positive. So I haven't answered your question other than saying that give me another lecture. But right now, the most important thing is stay on the application side. Do you understand how this equation should be used given the sign that I gave you? So I haven't answered your question, but I'm telling you, trust me. But do you know how to use it? That's why I'm challenging you. I make a lot of attempt to explain physically what the continuity equation is. I haven't made any attempt to tell you how this equation comes about because it's more vague, and I have to wait until the right moment, which is at least another lecture. Okay, so yes?
When drawing a three-body diagram, how can we represent the force due to the flow?
Okay, this one I believe you're told to neglect gravity. So you don't care about any body force. The free body diagram for the flow is just simply coming in and out, and the force is F. That is all it matters on the free body diagram. And this is not a free body diagram, this is a control wall. You draw a free body diagram for static. Okay? But for a fluid problem, you draw a control wall. The only time we use a free body diagram is on that problem in the homework, where we draw a free body diagram of this block. Okay? That's only used for static. We are now doing fluid. Does that make sense? Other questions? Now is the time to ask. Yes?
You know that the velocity is the same for...
Okay, excellent question. You were given the problem statement that they are the same. Okay? It is in the problem statement. But it turns out in another 3 lectures, by way of Bernoulli, the velocity has to be the same. But that's later. So you're told the velocity is the same. It turns out you can find out on your own later on based on Bernoulli equation. Very good question because we're going to do that in the plate problem momentarily. All these questions will come in the plate problem in about 10 minutes. Except it's a whole lot worse because now I have 2 dimensions to deal with. All these fundamental questions, if you're struggling now, I have to stop. I have to slow down because it's hopeless when we go to 2D. Right? Other questions? Yes?
So when we sub out m dot for rho VA,
Yes?
that the V term in that rho VA, do we need to tweak the sign on that?
Okay, this is a $1 million question. So let's deal with the next step. Right, this is step 1, which is momentum. And you always, not always, some of you're going to forget to use the continuity. Why? I don't know. Just from experience, I know you will. So the other causing equation is the continuity, which is m dot, just like what's being said, rho VA. And it's the same at in and out because there's only one port. I just have to tell you this is in or out. They are the same. And I don't care. Right? The question now is, do I have to worry about the sign for the velocity in this rho VA? Remember what I told you? Continuity is a scalar. What does that mean to you? No sign, no direction. So you don't want the double count. This is a question half of you are struggling, I guarantee you. And I want to clarify that now. Rho VA is rho VA. No sign, no direction. The only caveat is velocity has to be perpendicular to the area. Right? Remember that? Are you with me? That's it. Whether it's coming in or out, I don't see it and I don't care. No sign, period. End of discussion. All this detail will kill you if you are not clear now. Relax, I'm being too stiff today. I'm pounding on you like you're in kindergarten. Questions? Yes?
Why don't you account for the pressure in the area?
Okay, so what happened to the pressure? Again, in the problem statement, you were told that you can neglect gravity and assume steady flow. That's a good question. In the problem statement, nothing is said about pressure. But this says it's a circular water jet. What does that mean, a circular water jet?
Atmospheric pressure?
It's a free jet, meaning the water is not in a pipe. It's free to come out from a nozzle. And once it comes out from the nozzle for an open jet, what did we say the pressure inside the jet is always? Atmospheric. Atmospheric. Okay. The reason for that will be proven to you in about 3 lectures when we talk about Bernoulli. But right now, all those, velocity being the same, are given. A circular water jet in many of the homework or in the test, when you're not told, then it's a free jet, meaning the pressure inside the jet is always atmospheric. Now what? So it's atmospheric, then what? Why didn't I even account for the pressure on this term? What happened to the pressure? Draw that on the control wall. Draw on this diagram the pressure acting on the control wall for me. Can you do that? What direction would they be? Inward and normal. Are you sure I have water going in the opposite direction when it come out? Are you sure? Yes. Again, I'm repeating myself the 4th time. Consider this control wall being submerged in water. You ask yourself, where would the pressure act? Always normal and inward. Of what magnitude? What magnitude of pressure on this box? How much the pressure? Atmospheric, 14.7 everywhere. So if you draw that, 14.7, 14.7. What happened to the force due to pressure in the x direction? 0. They cancel out. So I don't need to account for that. Do you understand that? Now, all these questions are important. I'm so glad you asked, because until now I thought you are way on top of everything. I don't know. I mean, how many of you have used the office hour yet? None. 1. You don't need that. This is not an easy class by no means. I'm not an easy grader. I'm sorry, but I just want to make sure you go out with good basic training. All right? Any more questions on this Tuesday? Have I answered everything that you want to know? And the answer is this from continuity. No more, no less. Yes?
If it didn't say that we can neglect gravity, how would that change the problem?
Okay, this problem, it won't change anything, because if there were gravity, it's only acting in the y direction, which is not something that's being asked in the problem statement. Okay? But for other problems, like the homework you have done today, it does matter. That nozzle, where there's the weight of the water and the weight of the nozzle, that does matter. Right? Does that help? Other questions on this very simple problem? Yes?
If we weren't neglecting gravity and the inflow and outflow were far enough apart, would we have to consider like a pressure drop due to?
No, I think you make the problem too complicated.
Okay.
Right? So where most practical problem, the pressure drop between the ceiling and my foot in air is inconsequential.
But if it was water, would it?
If it's water, in what sense? This whole thing is submerged in water.
Okay.
Don't make it too complicated. Think simple. Yeah, I don't want to confuse you, so I don't want to answer the question. Right? Just keep it simple. Yes?
So with problems like that nozzle where you're acting